won't take us too long. So my very first question, this says it's a parallelogram. All right, so you are missing 1 point, which is where they have the letter D up here in this corner. And they give you 3 of the points in the lovely parallelogram. So both pairs of opposite sides are parallel there. So let's look at point D up here in this upper left-hand corner. Could anybody tell me just the y coordinate of the point? Like, how high up is this? And I know this is tricky, but could you just tell me the y coordinate of that point? What do we think? What's the y coordinate of the point? This should be A. Okay, if you're like, what the heck, where did you get that? Okay, do you guys see this top line? Those 2 points are at the same height. Like I'm going over a certain distance to get to them, but how high you go up, that's going to be the y coordinate. So because that is the same horizontal line on both of those points, this one and this one should be the same. So if the y coordinate of this point they give us here is point C, if the y coordinate there is A, the y coordinate here has to be the same because they're exactly the same height. Now, I think the super tricky part of this is the x coordinate. So let me just draw you like a tiny little triangle here. So if I go, let's see, we're trying to get the x coordinate of point D. Let me go all the way to the edge here where we have the points B and C. I am going to drop just a little bitty tiny vertical line, and I'm going to make just a little tiny right triangle right here with that side of the parallelogram as one of the, or that would be the hypotenuse of that little triangle I just drew. Okay, now, if I go to point B, I go over B, and then I don't go up or down, so that's why the y coordinate is 0. If I continue to go over farther, the base of this triangle, that puts me underneath this point. So if I go all the way over here, and I know this x coordinate, it would be how far I go to the right. This is B plus C. Does anybody know what the bottom of, like the little bottom of that triangle, what would that length be?
C.
C. Does that make sense? So if this has to be C, because if this point is B plus C, we're just going a little bit farther to get underneath that. We go up A, and I'm not trying to confuse you, but that has to be C. Now, because this is a parallelogram, I can actually just back up to this other vertex. This is the one we're trying to find. And I can drop a vertical line just like that. And I'm going to draw you, this is, if I had drawn it perfectly, an identical little right triangle. If I do that, the base of this triangle would be the same, which would be C. So, can anybody tell me the x coordinate of this point? It is C. Yes, it is C. So, to get underneath that point, I start at the origin, I go over just the distance of that little base of that right triangle, and then I go up to get to it, so the distance I go over to the right would match this little distance right here, which is just C. And those, I think, especially if you're working with a parallelogram, I know those are super tricky, how they're placed in the coordinate plane. Some of these other shapes might not be as terrible, but I know that the parallelogram tends to be really tricky for people. The y coordinate of both of the points across that top line has to be the same because they're at the same height. And then the distance here, this is C, this little triangle is identical, so they have the same base. That is the distance I'm traveling to the right to get underneath this point, and then I go up A to get here. Is anybody having a question? Okay, this guy right next to it is an isosceles trapezoid. That means you have 2 sides that are parallel. That's going to be the 2 horizontal lines there. And an isosceles trapezoid means the other 2 sides that are not parallel are congruent to each other. So we're just going to look here. This is placed, so the middle of this trapezoid is right on the x-axis. So it'd be like if I folded it on top of each other on that x-axis, those 2 sides would match up. So it's centered right there, but it's all in the first quadrant. It's all on that right side of the y-axis. Can anybody tell me, just looking at what they give you, they give you point Q here, and they give you point R here. So Q is 0, because you're not going left or right, and then up 1/2 A would be what the distance is here. The point R, this would be how far you're going right, they're labeling that with an A. And then to get to point R, I would go over A to the right, and then I'd go up B. So that would be that distance there. Can anybody tell me point, let's say point T? What would the coordinates of point T be? Like, how are you going left or right? That's your first quadrant, or that's your first coordinate. And then how are you going up or down? That's your second coordinate. What do we think for, if I look at this point T right here, what would the x coordinate be? Are you going left or right? You're not. It just goes straight down, so that means the x coordinate is 0. Does anybody know what the y coordinate would be? It's 1/2 a. Okay, it's got to match this distance here. This is 1/2 a. The only thing that's different is we're going down, so we just put like a little negative, so it would be negative 1/2 a. And that's all you got to do. It's like a mirror image. So the x coordinate's the same. If they're on the same vertical line, they got to have the same x coordinate, and then this is just flipped over. So instead of going up 1/2 a, I go down 1/2 a. So there's a little symmetry there. What about if point R is A comma B? Does anybody know what point S would be labeled? Like if I took this point, and this point, they're a reflection of each other. Does anybody know? Tell me the x coordinate. What do you think? It's just A, and then you go, instead of going up, you go down. So we both go to the right, right? To get to this point, I'm going to the right, but this one I go down. Now the actual distance can never be negative, but where we're at in the coordinate plane, I'm going down B, so that's why it has a little negative in front of it. Let me have you guys look at this one. This is also an isosceles trapezoid, but this is placed a little bit differently in the coordinate plane. So for this one, this side and this side are going to be parallel, and then this side and this side are going to be congruent. They only want one point here, which is the point M. They give you, J's right here on the corner, so that's right on the origin, right at 0, 0. K is going over A, but then doesn't go up or down. It just stays right here on 0. And then they give us this point L, and that is A plus B, and the distance up here is C. Let me draw you a tiny little triangle here. I'm just going to drop a little vertical line right here, and I'm going to color this in just real quick so you guys can see it. So this is like outside the little isosceles trapezoid. Now, I know to get up to this point, this distance is C, because that's how far I'm going up. Can anybody tell, based on looking at the coordinate K and the coordinate L, like what would the bottom of this little triangle be? So to get to K, I'm going over A. To get to L, I have to get underneath that. I have to go a little bit farther, and then I go up. What would that distance at the little bottom of that triangle be? Brody, what do you think? Perfect. You were saying it, B. Okay, now, let me come over here. I could draw you an identical triangle over here on this left side of this isosceles lovely trapezoid. This would be totally congruent to the one I just drew. This distance would then have to match the bottom here. So these would both be B, this would be C. If you know that, could you describe this point, the point M? Like what would the coordinates of that point be? What would your X be? What would your Y be? Go ahead. Perfect. Negative B. The distance is always positive, but I'm going to the left, so we just put a little negative in front of it, and then you go up C. Whatever you go up or down, that's your Y coordinate. Whatever you go left or right, that's your X coordinate. Very tricky. Is anybody having a question? Okay, let me have you guys do one more. This is a rectangle. So they only give me 1 point. The center of this rectangle, though, is at the origin. So this is all centered. So like if we'd fold this in half on the y-axis, the two sides would match up. Or if we'd fold this in half on the x-axis, the two sides would match up. So they give us they give us 2 points. This point U is 2AC. This point V is 2A comma negative C. And we're missing T and W. Can anybody tell me what point T should be? What do we think? What should point T be? if you want to go back to the point they give you real quick, this guy, to get to U, you're going over 2A, and then you go up C. If you do the point V, you go over 2A, and you go down C, which is why you have a negative in front of the C coordinate. If you go right or if you go up, those are positive directions. If you go left or you go down, those are negative directions. So if this is a rectangle, what would point T be over here in this quadrant? Negative 2A. What would your y coordinate be? Perfect. All right, and you guys see the two across the top, they have to have the same y coordinate. They're the same height. The only reason this is negative 2A, this distance is 2A, but I'm going to the left. That's why. And then you go up C. What would point W be? Am I going left or right if I'm trying to get to this point? Left or right? Left. Okay, so it has to be negative. X coordinate is how you go this way. So it'd be negative 2A. What would the y coordinate of that point be? Negative C, because you're going down C. The distance would be C, but the actual, where it's placed in the coordinate plane, we just have a little negative in front of it. Is anybody having a question? Okay, let me have you guys look at this one. So we're actually trying to use this to do a coordinate proof here. And I've got an isosceles trapezoid placed in this lovely coordinate plane here, which means isosceles trapezoid, just real quick, I'm going to jot this down for you. The segment from D to C congruent to the segment from A to B. I'm just not going to draw it in the diagram because it's going to garbage it up a little too much. But the left side and the right side of that would be congruent to each other if this is an isosceles trapezoid. Now, they say in the directions here that these other points they've got labeled, they've got an E, F, G, and an H. Those are midpoints of each of the sides. And we're going to draw the mid segment is what it asks you to. Okay, a mid segment connects two midpoints. Now, if you're working with the trapezoid, the mid segment of a trapezoid has to be parallel to the top and the bottom. So there's two ways I could connect two midpoints here. We could connect E to G, but that's not going to be parallel to the other two bases there. So the mid segment we want to draw in here is going to connect H to F, and that's what we're going to play connect the dots with. So just do your best to draw a line right here. HF would be your mid segment. Now, can you tell me, and you might be able to figure this out, but we could use the midpoint formula if you want to. I think you could maybe figure it out from the diagram. I want to find the coordinates of H and F here. All right, so remember, H is right in the middle of D and C, and over here, F is right in the middle of A and B. These are going to be similar, but they're on different sides of the X and Y axis, so we got to think about that for a second. If I'm at H, okay, X coordinate of C is negative 12A. X coordinate of D is negative 8A. Whenever you find a midpoint, it's the average of the two X coordinates. If this is negative 12A and this is negative 8A, anybody have any idea what the X coordinate of H would be? If we got negative 8, negative 12, what would be right in the middle? Think about that for a second. If you're between, and you can think of it as positive too, it doesn't matter. Right? What's the number that would be right in between 8 and 12? 10. Okay? That's all it is. So this would be negative 10. You just put an A with it. Now, the y coordinate, so my two y coordinates, I got 4b and I got 0. What would be right in between 4b and 0? Or what would just be right between 4 and 0? 2, exactly. You're just going to put a b with it. So this is 2b. So that's your point. I'll just write it here. H, negative 10A, 2b. Okay. What would be, on this side, very similar, what would be right in between positive 8A and 12A if I'm looking at the point where F is at? What would be right in between 8A and 12A? 10A. There you go. What would be right in between positive 4B and 0? Positive 4 and 0. 2. There you go. This is just 2b. These guys have to have the same y coordinate because they're at the same height. So there's your f. We're going to grab those 2 points. All right, my dear. Let's see. This is going to be 10a, 2b. All right, is anybody having a question? It's not terrible to do. All right, now I'm going to use this diagram. We're going to do a little coordinate proof. I promise this is not as bad as it looks. I don't know if you guys remember doing this from the trapezoids the other day. If you have a mid-segment of a trapezoid in this picture, I'm just going to write this down. The 2 bases, if you add them together, the mid-segment is an average of the 2 bases. So I'm going to write it for this diagram real quick. HF, which is my mid-segment, is an average of the 2 bases, so the top and the bottom. So it doesn't matter which one goes first or second, but I'm going to say DA is across the top and CB is across the bottom. Those are the 2 bases, and it's an average of those. So we would add it up, divide by 2. Mid-segment is going to be an average of the lengths of the 2 bases. Now I promise this is not as bad as it looks. So, why do I not have the colors up here? Grab this. All right, let's look at finding the lengths of these segments real quick. So from D to A, if I go just based on the points that they give me in the diagram, if I go just to get under the point where A is at, I'm going over 8A. So that would be the distance. Does that make sense to you guys? Like if I go from the origin, which is the point G, I go over to get underneath here. So that distance should be the length of that little segment. This guy is exactly the same. What would you tell me the length of the segment from D to A is? What do you think? Perfect, 16A. All right, I'm going to prove this to you guys here. So this one we just did, right? We said we're going over 10A here. We're going left 10A here. What would the length of that mid-segment, which is HF, be in that diagram? 20A. All right, and then across the bottom, I didn't really focus on this yet, but from C to B, can anybody tell me the length of that segment? And again, it's matching up with the x coordinate. That's how you're going left or right. So this side would be 12A. This is going left 12A, but the distance is going to be positive. So what would the length of that segment be? 24. Okay, now, here's all you have to do. I'm just literally going to plug this information into the formula for mid-segment to prove this. So we said HF, which here is this. This is 20A. This is supposed to be equal to this. We're going to do this as a little proof. D to A is 16A, and C to B was 24A, and it's supposed to be an average of those 2 lengths. Divide by 2 here. All right, now, nothing you can do on that left side. That's just 20A. Can I add together 16A and 24A on the top of that fraction? Okay, what does that add up to? Does anybody know? 40A. All right, can I divide that by 2? What would that be? So you just did a proof, just right there. Those expressions are exactly the same, so then you know that that's correct. Is anybody having a question? Okay, here's what I'm going to do. I'm going to stop right there from today, and I'm going to help you out